Today I am taking lecture on effects and control of air pollution. So here we are seeing the picture of some effects of air pollution on the human health and the plants. Asthma, cancer, there may be some brain problems, irritation of the eyes, nose and throat, problems in pregnancy, and here doctor is saying there may be chances of the type 2 diabetics. Now effects of the air pollution on the plant. Due to the sulfur dioxide there is bleaching of leaves, necrosis. Necrosis means killing of the tissues. This is types of the cancer in the plant. Nitrogen dioxide effects suppress growth, bleaching. Ozone suppress growth, bleaching, necrosis, collapse of leaf. So if we are there is harvesting of the leafy plants, so there is loss of the harvest. Fluorides, necrosis in leaf tips. Pan, suppress growth, silvering of the lower leaf surface. Here again the some effects of the some air pollutants on the environment. So no need to discuss in detail here. Just we have already seen the some effects of the general air pollutants on the human health and the plant. Now effects of the industrial air pollutants on the human health. So here are some specific air pollutants which comes from the certain types of industries, and they retain only that around that industrial zones, not the impacted the all of the regional level or the global level. So the arsenic, this is the suspected carcinogen, causes bronchitis and irritation. Asbestos, pulmonary tuberculosis, asbestosis, barium, cardiovascular and nervous system. Boron, toxic, damage to nervous system. Cadmium, damage kidneys, causes diseases of heart and liver. Chromium, toxic substance, suspected carcinogen. Mercury, adversely affects protoplasm. Phosphorus, skin irritation, affects nervous system. Radioactive substances, cancer, leukemia. Zinc, damages mucous membrane. Now here the global effect of the air pollution. This is the one of this is the greenhouse effects. So we have to understand the what is the greenhouse effect. As in colder regions, they want to grow the plants, but they are unable because there is much cold is available. So plant cannot grow there. So in that case, they do the plantation and covered that area by the glass. So as the sun's short waves enter in this glass and heated that area. So now this is the these gases convert this sun rays which are coming as a short wave converted into the heat rays. This is the form of the infrared or long wavelength. So certain infrared which cannot pass through the glass and retain inside that glass chamber or house, but long wavelength radiate to the atmosphere. So in that way the infrared retain there and they create the warmer atmosphere for in favor of these plants. Now see in this picture actual what is happening in the earth. Sun rays are coming from the coming through the different atmosphere and reaches on the earth surface. So some portion of these rays reflected back in the atmosphere, some through the clouds, some through the aerosols, and some due to the other particles available in that atmosphere. Around 50% this sun rays absorbed at the earth's surface, and 4 to 6% the light reach the earth's surface reflected back into the atmosphere. So this is the normal phenomena and normal temperature on the earth. Now see what is now happening. So when the certain greenhouse gases emitted from certain industrial activities or man-made activities, so these gases form a extra layer, or we can say thicken the exist layer of these gases. So what sunlight is reaching on the earth, so it is going back in the atmosphere, but due to the thickness of of these gases, or the extra layer of these greenhouse gases, this heat came back on the earth. This phenomena is continue going on, and due to this phenomena this greenhouse effect exists, and due to this greenhouse effect global warming happens. So here some impacts of the greenhouse effects. The temperature on earth may increase by about 1.5 to 4 degrees centigrade by the year 2050. As a result of increased temperature, the polar ice caps may melt vigorously, and there would be rise in ocean level, threatening the population near the coastal zones. The flora and fauna would also be adversely affected by the increased temperature. Some of the organisms may become extinct, as they may not be able to tolerate the high temperature. Human health could similarly get affected. Sudden changes in the climate, formation of cyclones, stability of seasonal cycles are expected to occur. As you have seen, many birds which were earlier we are seeing, but now they are not available. Maybe that this is effect of the some directly and indirectly effect of the greenhouse effect or global warming. Ozone layer depletion. This is also the global effect of the air pollutants. Chlorofluorocarbon is extremely stable. It does not dissolve in the rain and rise up into the atmosphere efficiently. But strong ultraviolet rays break down chlorofluorocarbons, which releases chlorine atoms. The chlorine atoms bond with one of the oxygen atoms in an ozone molecules. The other two atoms become an oxygen molecules. The chlorine and oxygen atom becomes chlorine monoxide, but the oxygen will bond with another free oxygen atom to form a separate molecule. The chlorine atom is then free to destroy more ozone molecules. It is estimated that one chlorine molecule is capable of destroying over 1 lakh ozone molecules before it is finally being removed from the stratosphere. So here the same reaction what earlier I explained. The chlorofluorocarbons is available, and this is convert CFCl3. Now this is break into CFCl2 plus Cl, and this free atom of chlorine react with the ozone which is available in stratosphere of the atmosphere, and the make the product the compound chlorine monoxide, and oxygen molecules is remain here. Then this chain reaction again release the chlorine and oxygen, again add the another oxygen atom, make the oxygen molecules, and this chlorine atom again react with the ozone, and this reaction is continue going on. So as there in some places there is the ozone layer is thinning, so this ultraviolet may reach the or reaching on the earth and giving the negative impact. So global use of the chlorofluorocarbon aerosol, this is 25%, foam insulation 19%, solvent 19%, air conditioning 12%, refrigerant 8%, flexible foam 7%, others 20%. Though, so another effect of the air pollutant, this is the acid rain. This we can say this may be the regional effect or local effects. So there is the certain air pollutants, sulfur dioxide, nitrogen oxides are available. They form the sulfuric acid or nitric acid because there is the some water vapor is available. So this is the dry deposition. But when rain is falling, so this acid mix with the rain and come down on the earth, and this is the wet deposition, and this is the effect on the certain different types of growth of the plant, and they impact on the building structure also. Now air pollution control approaches. Pollution prevention: to reduce, eliminate or prevent pollution as its source. For example, farmers can reduce air pollution by conducting hazard reducing burning at times when smoke impacts are likely to be minimal. This is the pollution prevention. Clean Air Technology Center. This serves as a resource control technologies, including their use and effectiveness. For example, we are using the wet scrubber, fabric filters, electrostatic precipitators, condenser, absorbers, adsorbers, and biological degradation. Controlling emission in transportation. This can include emission control on vehicles as well as use of the cleaner fuels. Economic incentives such as emissions trading and emission caps can be used. These strategies may be combined with the regulation which have been used by the air pollution control agencies. Factors in designing air quality control strategy. Environmental factors such as ambient air quality conditions, relevant meteorological conditions, location of the emission source, noise levels, and any ancillary pollution from the control system itself. Engineering factors such as pollutant characteristics, gas stream characteristics, performance characteristics of the control system, and adequate utilities. Economic factors such as capital cost, operating cost, equipment maintenance, equipment lifetime, and administrative, legal, and enforcement cost. Dilution. Tall chimneys discharge the contaminants at a higher level from the ground where they get diluted in the atmosphere. Thus, the concentration of contaminants at ground level are greatly reduced. Control at source. The pollution at source can also be considerably reduced by adopting one or more of the following strategies: changing the location of the industry, changing the type of the fuel for the industry, changing the process of manufacturing, and installation of properly designed air control equipment devices that help in reducing particulate matter, and devices that reduce gaseous pollutants. So now the gaseous pollutant control from stationary source. The most common method for controlling gaseous pollutant is the addition of add-on control devices to recover or destroy a pollutants. There are four commonly used control technologies for gaseous pollutants: absorption, adsorption, condensation, and incineration. What is the absorption? Absorption is a physical or chemical process of removing a pollutants from a gas phase media by dissolving the pollutant into a solvent medium. Solvent media is most commonly a liquid phase. The material that absorbs is called the solvent. and the gas that is to be absorbed is called the solute. The most common form of absorption is wet scrubbing. One potential problem with absorption is the generation of the waste water. So here we are removing the air pollution but producing the waste water. Here we are seeing the process. The gas stream that contains the pollutants to be removed enter from the bottom of the scrubber, as we are seeing picture, and quickly turns upward towards the exhaust at the top of the scrubber. The random packaging provides necessary surface area to distribute the liquid solvent and encourage contact between the two medias. The liquid scrubbing media or solvent enters near the top of the scrubber and is distributed over the random packing. The liquid absorbs the pollutant from the gas phase and is collected in the sump. Prior to exiting the scrubber, the gas phase passes over a mist eliminator and exits to the atmosphere. Now adsorption. Adsorption is a mass transfer process in which a porous solid comes in contact with a liquid or gaseous stream to selectively remove pollutants by depositing them onto the solid. The contaminants being removed are referred to as the adsorbate, and the solid doing the adsorbing is called the adsorbent. The most common industrial adsorbents are activated carbon, silica gel, and alumina because they have enormous surface area per unit weight. Carbon adsorption systems are either regenerative or non-regenerative. Regenerative system usually contains more than one carbon bed. As one bed actively removes pollutants, another bed is being regenerated for the future use. Non-regenerative systems have thinner bed of the activated carbon. In a non-regenerative adsorber, the spent carbon is disposed of when it becomes saturated with the pollutants. Here we are seeing the in picture adsorbent, there are distributors and adsorbent inlet. So the most efficient method for promoting adsorption is in a packed bed through which the polluted air stream being treated. This is passes from here as the through this adsorbent. The stream passes through the bed, adsorption of the contaminants take place, and the purified air exits the packed bed. Condensation. Condensation is a process to convert a gas or vapor into liquid. Any gas can be reduced to a liquid by sufficiently lowering the temperature or increasing the pressure. Condensation can be used to remove a pollutant from a gas stream if the dew point of the pollutant is higher than the carrier gas, which is a non-polluted gas. The most common form of condensing is by lowering temperature, while increasing pressure can be equally effective, but this is the more expensive process. Condensers are simple and relatively inexpensive devices that normally use water or air as the coolant. Condensers are typically used as pre-treatment devices. They can be used ahead of the adsorbers and insulator to reduce the total gas volume to be treated by the more expensive control equipment. So here the mechanism. Condenser work when the warmer vapor stream contacts a cooling medium. The heat from the warm gases is transferred to the cooler medium. Then as the warm gas stream begins to cool, the kinetic energy of the gas is reduced. Condensation occurs because the pollutant molecules are slowed and crowded so close together that the attractive forces between the molecules cause them to condense into a liquid. Condenser used for pollution controls are two types: contact condenser and surface condenser. In a contact condenser, the gas comes into contact with cold liquid. In a surface condenser, the gas contacts a cool surface, not the liquid, in which cool liquid or gas is circulated inside it, such as the outside of the tubes or inside of the tube. Incineration. It can be defined as a rapid combination of oxygen with a fuel. This process will result in the release of energy in the form of heat, carbon dioxide, and water. The air control industry typically refers to the equipment which perform this process as oxidizers. Equipment used to control waste gases by combustion can be divided in three categories: direct combustion or flaring, recuperative thermal incineration, and catalytic incineration. Direct combustor. It is a device in which air and all the combustible waste gases react at the burner. Complete combustion must occur instantaneously since there is no residence chamber. A flare can be used. The process stream is heated up to thermally oxidize the volatile organic compounds in the process stream. This is usually a temperature of 760 degrees centigrade or maybe higher, depending upon the volatile organic compounds to be destroyed. Recuperative thermal incinerator. The combustible waste gases passes over or around a burner flame into a residence chamber where oxidation of the waste gases is completed. This technology is similar to direct thermal oxidizer, except recuperative thermal units use a heat exchanger to recover heat from the oxidizer exhaust and preheat the incoming process air to conserve fuel. Catalytic incinerators. These are very similar to thermal incinerator. The main difference is that after passing through the flame areas, the gases pass over a catalyst bed. The purpose of catalyst is promote oxidation at lower temperature. Then thereby this is reducing the fuel cost. Particulate control. Mechanical collectors like the dust cyclone, multi-cyclones, electrostatic precipitators, bag houses, particulate scrubbers. Scrubber, baffle spray scrubber, cyclonic spray scrubber, ejector venturi scrubber, mechanically added scrubber, spray tower, and wet scrubber. Now cyclone. A cyclone removes particulates by causing the dirty air stream to flow in a spiral path inside a cylindrical chamber, as we are seeing in the figure. Dirty air enters the chamber from a tangential direction at the outer wall of the device, forming a vortex. As it swirls within the chamber, the larger particulates, because of their greater inertia, move outward and are forced against the chamber wall. Slowed by friction with the wall surface, they then slide down the wall into a conical dust hooper at the bottom of this equipment. The clean air swirled upward in a narrower spiral through an inner cylinder and emerges from an outlet at the top. Accumulated particulate dust is periodically removed from the hooper for disposal. Electrostatic precipitator. The electrostatic precipitators works by removing particles and smoke from a gas stream using an electrostatic charge. Dust particles travel past wires that have a high direct current voltage which is applied, which ionizes the surrounding gas. This corona discharge causes the particles to pick up a small electrostatic charge. An oppositely charged plate attracts the particles, neutralizes and retains them. A regular tapping of the plates then physically removes the collected particles, as we are seeing in figure. So negatively charged particles attracted by the positively charged plates. Bag filters. Bag filters use fabric bags to remove particles from dust-laden gas. As dust-laden gas enters the bag house compartments, larger particles drop out into the hopper and small particles collect on the filter bag or media, forming a layer or cake. Clean gas passes through the media. Mechanical shaking using a reverse airflow or a pulse of compressed air are used to dislodge the dust from the fabric surface, which then falls by gravity into a collection system. Biofiltration, an air pollution control technology which utilizes microorganisms to biologically degrade odors and other volatile air pollutants contained in waste air streams. The microorganisms exist on the surface and in a thin water film surrounding the surface of the biofilter material. The pollutants are absorbed onto the material surface and absorbed into the water film. Simultaneously, the microorganism metabolizes the pollutants, producing energy, biomass, and metabolic end products, mainly carbon dioxide and water. As we are seeing in the picture, the whole process. So all this is about the technology we are using in the industry or the manufacturing unit from where air pollutants are coming out, and before entering in the environment, these air pollutants are trapped in due to these technologies, and completely the clean air reaches exists from the these industry. This is all about. Thank you.